everyone. Welcome to Robert Morris University Math 0900. This is Brianne Pernick, and we are going to now begin working on Chapter 4, Lesson 1. In this lesson, we are going to work on using the product rule to multiply exponential expressions with like bases, using the quotient rule to divide exponential expressions with like bases, and raise exponential expressions to a power. There are some vocabulary words that I need you to make sure that you know before the end of this lesson, and those are exponents, base, exponential expressions, and numerical coefficient. I do believe that we have discussed all of them at some point during this course, so you should be familiar with them, but if not, please make sure that you do review. The first rule that we are going to talk about is what's called the product rule. So what I would like you to look at is the example that I have here, where I have given you the problem of a to the fourth times a to the second. Now you have the option of putting that problem in expanded form, where we have a times a times a times a times a times a. If you count your a's, you're going to see that you have 1, 2, 3, 4, 5, 6 a's, giving us a to the sixth. Remember that exponents show us repetitive multiplication of a number that has the same base. We are not going to do every single problem longhand like this. What we're going to do is observe a pattern and use a rule to do these problems. Imagine if we had a to the 100 times a to the 60. We don't want to write 100 a's and 60 a's and count them and put them all back together again, right? We would hope that there is some kind of shortcut or some type of rule that we can follow that would allow us to do that problem significantly faster. And luckily for us, there is. We have what's called the product rule. And the product rule allows us to multiply two exponential expressions by keeping their base the same and adding their exponents. And please note that they have to have exactly the same base in order for this to work. So if you have x to the a and x to the b, and they're being multiplied, you would simply add a and b and keep your x. So let's take a look at a few examples, and then I'm going to have you guys do some of these on your own. Letter A, we have x cubed times x to the sixth. Our base is the same, and we're being asked to multiply. So we're going to keep the base, and we are going to add the 3 plus 6. So 3 plus 6 makes 9, so the answer is x to the 9th. Letter B, we have x to the first times x to the fifth. We keep the base the same and add the exponents, so we have x to the sixth power. Letter C, we have 2 cubed and 2 to the fifth, so we're going to keep the base the same and add the exponents, so 3 plus 5 makes 8, 2 to the 8th power. Whenever your problem is numerical, you should evaluate that. So 2 to the 8th power becomes 256. And then letter D, we have x to the 6th, y to the 6th. Please note that those bases are not the same. And since the bases are not the same, we cannot do anything further with this problem. So the answer is simply x to the 6th, y to the 6th. I would like for you guys to go ahead and try a couple of these Actually, before I set you loose, let me show you how to do a couple of these on your own, a couple of these first, because they have coefficients, and then I'll have you try some. These ones introduce the problems having a coefficient with them. So we're going to follow the same rules here. We're going to start by multiplying our coefficients. So 2 times 3 makes 6. And then we follow the same exact product rule. We keep the base the same and we add the exponents. So 5 plus 6 makes 11. Letter B, we have 5 times a coefficient of 1 makes 5. And then you're going to keep the base the same and add your exponents. 3 plus 6 is 9. Why don't you guys go ahead and try letter C and do letter C. Go ahead and do letter C, pause the recording, press play when you're ready. Okay, by now you should have had an opportunity to complete letter C. You should have multiplied your coefficients of -6 and -5 and had positive 30. And then we would keep the base the same for the exponents. And then you would add the exponents of 1 and 5 to get x to the 6th. Now, letter D is one that I wanted to walk you through first with me before I let you loose on it. So as you're looking through here, we have a positive, a negative, and a positive. I taught you a trick a while back that whenever you had an odd number of negative signs, your answer would always stay negative. So we're going to go ahead and bring that negative sign down so that we don't have to even think about it and worry about it. And now we're going to look at our coefficients. We have 5 times 1/3 times 9. As I look through this, the first thing I see is a fraction. I don't like fractions. I don't like dealing with them. I want to check for cross-canceling to see if I can get rid of it. So I'm going to look at the 3 and the 5. Can't cross-cancel that way, but I can cross-cancel with a 3 and a 9. My 3 will become a 1, my 9 will become a 3. So now I am multiplying 5 times 1 times 3, which is just 15. And now we can multiply our variables. I have a times a, which makes a squared when I add my exponents, and b times b squared, which makes b cubed when I add my exponents. I would like you guys to try letter E on your own. You're going to do it very similarly to the way that we just did letter D. Please pause the recording and press play when you're ready. Okay, by now you should have had an opportunity to complete letter E. As you're moving through this problem, we have 2 times 5 times -3/5. So we have 2 positive coefficients and a negative coefficient. Whenever your number of negative signs is odd, your answer will be negative. So I'm going to go ahead and write that negative sign down there so that I don't forget about it. I'm going to check for cross-canceling to see if I can get rid of my fraction. I can. I'm going to cross out my 5s because they will cancel each other out and become 1s. So now I can do 2 times 3 to make 6. And I'm going to start multiplying my r's. R squared times r makes r cubed. And s times s to the 4th makes s to the 5th. The next topic that we are going to talk about is the quotient rule. Before we start this topic, I do want to remind you that division by 0 is undefined. For the purposes of this section, please assume that none of the variables that we're going to work with are equal to 0. So we're going to start with an example that has x to the 5th divided by x to the 3rd. As you look at this example, excuse me, we could very easily put this example in expanded form, just like we did at the beginning of the other section that we covered. We could allow our x's to cancel each other out and see that we're going to have 2 x's remaining, multiply them back together, and have an x squared. Again, we would not want to do every single problem longhand. Imagine if our variables were huge. That would take us a very long time to have to do every single problem longhand like that. What we would want to do is observe a pattern and use a rule to help us with these types of problems. And the rule for dividing is that the variables from the numerator and denominator can be subtracted. If you look at the problem that we just did here, 5 minus 3 makes 2. So the quotient rule is that you're going to subtract the exponents for the numerator and the denominator. So we'll keep the base the same and subtract a minus b. And you would use that form if the larger of the exponents is in the numerator. So let's take a look at a couple of these examples. The first example is 2 to the 16th over 2 to the 11th. We're going to go ahead and keep the base the same, and then we're going to do 16 minus 11. And that's going to give us 2 to the 5th power. We could then go ahead and evaluate that since it's a numerical problem. But for now, we'll just leave it as 2 to the 5th and move on. The next problem that we have is x to the 5th over x to the 3rd. So we would take x to the 5 minus 3 and get x squared. Why don't you guys go ahead and do letters C and D for me? Please pause the recording, complete letters C and D, and as soon as you're ready, please press play. Okay, by now you should have had an opportunity to complete letters C and D, and you should be ready to check your answers with me. For letter C, you're going to keep your base of y the same, and you should have subtracted 10 and 7. So 10 minus 7 makes 3, so our final answer is y cubed. For letter D, you should have kept your base of b the same, and we're going to subtract 6 minus 1, so our final answer is b to the 5th. Excuse me. Now, part 1 of the quotient rule works really well whenever the exponent in the numerator is larger than the exponent in the denominator. When the exponent in the denominator is larger, we have to use the following rule to avoid getting a bigger, to avoid getting a negative exponent. We do not ever want to have a negative exponent because it's considered to be unsimplified. Okay, so if you have a larger exponent in your denominator, what you would want to do is make it 1 over your base, which our base in this example is 12, to the b minus a, so your denominator minus numerator exponent. So we have 20 minus 17, and that gives us 1 over 12 cubed. 1 over 12 cubed. Example B. We have b to the 7th over b to the 9th. That one tells us that the denominator's exponent is bigger, so we're going to do 1 over b to the 9 minus 7 and get 1 over b squared. Why don't you guys go ahead and try letters C and D for me? Okay, by now you should have had an opportunity to complete C and D. We should have had 1 over 15 to the 26 minus 12, which makes 1 over 15 to the 14. And then letter D, we should have had 1 over r to the 4 minus 1, which makes 1 over r cubed. Now, I want to show you just one other way to do this, because some of you may automatically just subtract those and not necessarily see that your denominator is bigger. And the second way that I'm showing you is actually how I do these. I don't necessarily follow the quotient rule part 2. What I do is I just automatically start subtracting my exponents. So I would do 12 to the 17 minus 20. And I would get a negative exponent. But I recognize that a negative exponent is unsimplified. And I know that that has to be simplified by making it a fraction with a 1 in a denominator. So I would automatically write that as 1 over 12 cubed, which is exactly the same answer that we had before. Letter B, we have b to the 7 minus 9. You would get b to the negative 2. You would say, uh-oh, I'm not allowed to have a negative exponent. That's bad. So you would write that as 1 over b squared. That negative exponent is going to switch places. It's going to go from the numerator that it's currently in to a denominator under 1. Same answer we had a minute ago. Letter C. You have 15 to the 12 minus 26 power. When you simplify, we had 15 to the negative 14. And then that becomes 1 over 15 to the 14th power when we simplify. And then lastly, letter D is r to the 1 minus 4. When you do the math, it becomes r to the negative 3 power. Can't have a negative exponent, so it becomes 1 over r cubed. Okay, next. Division problems can contain numerical coefficients, just like they did with multiplication. So what you want to do here is start by dividing those coefficients, and then second, divide the exponents. So I'm going to start with 5/25. I want to think of that as a fraction. I want to think of that as a fraction. If I have 1 or 5/25, what will that reduce to? Well, it would reduce to 1/5. So I'm going to go ahead and write my 1/5 there. Now, if I had my x to the 5th over my x to the 7th, we would do x to the 5 minus 7 and get x to the negative 2. And x to the negative 2 is unsimplified. we would say that the negative 2 would not be able to be written in that numerator. We would want to put that as a 1 over x squared, which would mean that it has to go into the denominator. Now, that should make sense to you. Imagine expanding out the 5 x's that you have in the numerator and the 7 x's that you have in the denominator. If you started canceling out those x's, you would have 2 x's left in your denominator. All right, let's look at example B. We have negative 12x to the 8 over 4x cubed. So let's think of this as a fraction. We have negative 12 divided by 4. That's going to make negative 3. And now we have x to the 8th over x cubed. We have to subtract those exponents, so we have x to the 5th. Now that exponent is positive, so I don't have to worry about moving it at all, which means that that fraction went away. I don't even need to worry about that being a fraction. The next example, we have negative 16x to the 7th over negative 24x to the 8th. A negative over a negative becomes a positive. So let's focus on reducing that fraction. 16 over 24 can be reduced by 8. So 16 divided by 8 becomes 2. 24 divided by 8 becomes 3. And now we must focus on the x's. So if I had x to the 7 minus 8, that gives me x to the negative 1. Do we want to put that x to the negative 1 in the numerator or in the denominator? Well, since it had a negative, I don't want to put it in that numerator. I want to put it down in the denominator. So I have 2 over 3x. The next topic shows that when 2 or more variables are involved, we're going to divide each, including any coefficients, separately. So let's start working on that. Example A. I'm going to start by drawing one big fraction bar. Example A, I have a 1/5, but I can't do anything with the 1/5. It's already considered to be reduced, so I'm just going to leave it the way it's written. And now I'm going to work on dividing my x's. So I have x cubed over x. The way that we're supposed to simplify that is by subtracting those exponents. So we're going to do x cubed and take away the 1. Think of it as x to the 3 minus 1. That leaves us with x squared in the numerator. And then we're going to work on the y's. The y gives us 2 minus 6, which is y to the negative 4. Since it's a negative 4, we're going to go ahead and put that down in the denominator with a positive 4. So we have x squared over 5y to the 4th. Letter B, I'm going to draw in my fraction bar, and we're going to focus on reducing my coefficient, my x's, and my y's. We have negative 3 over 12. Think of it like 3/12. How is negative 3/12 going to reduce? Negative 3/12 can be reduced by 3, so that's going to make negative 1/4. Next we have our x's. That's like x to the 2 minus 6, which is like x to the negative 4. We have to put that in the denominator, and it is a positive 4 once you move it down, sorry. And then we have our y's. We have y to the 5 minus 8, which makes y to the negative 3. That also needs to move to the denominator since it was a negative. So we have negative 1 over 4x to the 4th y cubed. And lastly, we have letter C. We have 15r squared s to the 7th over 5r to the 6th s. So we're going to start with our numbers. 15 over 5 makes 3. Then we have r to the 2 minus 6. That makes r to the negative 4. I want to put that in my denominator so that I can write that as a positive 4. And then I have s to the 7 minus 1, which gives me s to the 6th. That can go in my numerator since it has a positive exponent. Now we have one more part of this quotient rule. And that quotient rule says that if we subtract and get a 0, that is equal to 1. And the reason for that, if you think of, let's look at the example of 2 over 2. That's like 2 to the 1st over 2 to the 1st, right? We should all agree with that. If I subtract 1 minus 1, I'm going to get 2 to the 0, right? But if I just thought of my 2 over 2 from before, that would make 1, okay? So any number over itself will always make 1. But when you subtract those exponents, they're going to make a 0 and also cancel to 1. So that's the math behind that rule. A lot of people sometimes have trouble understanding the abstractness behind it, so I do like to show why an x to the 0 becomes a 1, and it has to do with the canceling of the number such as 2 over 2, or even if we made it 2 squared over 2 squared, okay, and you subtract those exponents and we still get 2 to the 0. If you were to have evaluated that and made it 4 over 4, it's still equivalent to 1. So that's the math behind this part of the rule, okay? So we're just going to look at a few quick examples here. We have x to the 6th over x to the 6th. We're going to look at that. We're going to subtract those exponents, and we're going to get x to the 0, and we automatically say, oh, that's equal to 1. Letter B, we have 3 times x to the 5th over x to the 5th makes x to the 0, which makes 3 times 1. So that expression is just equal to 3. And then the next part, as we're moving through here, this becomes 4 times 1 times y squared over 1 times y to the 5th times z cubed. So there was a lot of simplifying that happened right there in that step, and we can continue to move on. We can have 4 over y to the 2nd minus 5 gives us y to the negative 3. That tells us that my y belongs in my denominator, and then my z cubed stays where it is. So that thing started out looking kind of ugly, but it finished looking a little bit better. Last concept here for the division section is that we can actually combine the product and quotient rules together to simplify algebraic expressions that involve both multiplication and division. What I need you to remember here is that we have those imaginary parentheses around our numerator and our denominator. So we need to take care of everything that's in the numerator first before we start worrying about dividing across the numerator and denominator. So we're going to actually start by multiplying across the numerator, across those quantities. So 8 times negative 3 makes negative 24. X squared times x cubed makes x to the 5th when we add those exponents. And y times y squared makes y cubed when we add those exponents. We're going to leave the denominator the same. It's negative 6, x to the 4th, y cubed. Now that we have simplified the numerator, we can now take care of division. So negative 24 divided by negative 6 makes positive 4. X to the 5th divided by x to the 4th requires us to subtract those exponents. 5 minus 4 makes 1, so that's just x to the 1st, which is x. Y to the 3rd over y to the 3rd makes y to the 0, which is going to become 1. So that whole mess of example A is just equivalent to 4x. Lastly, we have example B. We have to start by simplifying what's in our numerator first. So 4 times negative 9 is negative 36. A times a squared makes a cubed. B times b makes b squared. Over negative 30, a to the 6th, b to the 4th. Now we can simplify through division. A negative over a negative is always going to make a positive. 36 over 30 does not simplify into a whole number, but we can reduce the fraction by reducing out a 6. 36 divided by 6 is 6, and 30 divided by 6 is 5. So then we have a to the 3 minus 6 power, which gives us negative 3. That tells me that I want my a cubed in my denominator. And then I have b to the 2 minus 4 power, which gives me b to the negative 2, which tells me that I want it in my denominator with a positive exponent. So I have b to the 2nd power. I'm just going to erase that jumble and make it look better. Sorry. So I have b to the 2nd power. And that is our final answer there. Okay. Moving on. We are now ready to start talking about raising exponents to a power. So the first topic that we have is raising a power to a power. When you are raising a power to a power, you are going to multiply the exponents. So please recall what happens when you raise a negative number to a power. I need you to remember that trick that I taught you about that if your exponent is even, your answer will be positive, and if your exponent is odd, your answer will be negative. Okay, keep that trick in mind there. So let's walk through these series of examples that I have for us. Our first example is x cubed raised to the 5th power. When we're raising a power to a power, the rule states that we are supposed to multiply. So that means that we're going to have x to the 3 times 5 power, which gives us x to the 15. Letter B, we have 2 to the 7 times 3 power, which gives us 2 to the 21st. And then letter C, we have negative 1 being raised to the 8th power. When the power is even, the answer will be positive. 1 to the 8th power. The next concept is raising a product to a power. This rule tells us that if I have more than one item inside my parenthesis, I am going to be raising everything in that product to that power. So I have A to the 8th, B to the 8th. Letter B, I have the product of 3x being raised to the 4th. So that is going to become 3 to the 4th, x to the 4th. You would then want to evaluate 3 to the 4th and make that 81 x to the 4th. And then letter C, you are going to be raising negative 2 to the 3rd power and x squared to the 3rd power, which requires that multiplication. Please note how I put my negative 2 in parentheses, because you have to show that that entire negative 2 is a base. When your base is negative and your power is odd, your answer will be negative. So negative 8x to the 6th. Next, we have the ability to raise a quotient to a power. And when we're raising a quotient to a power, we will give that power to everything that's in the numerator as well as everything that's in the denominator. So if we have x over y being raised to the 5th power, then we would make that x to the 5th over y to the 5th. Letter B, we have a cubed over 5 cubed. So we would make that a cubed over 5 cubed. And then we would evaluate. So a cubed over 125. Letter C, we have some product to a power going on here. So we're going to take care of 7 cubed w to the 6th over 2 to the 4th w to the 4th. We then want to evaluate. So 7 cubed is 343 w to the 6th over 16 w to the 4th. Lastly, you want to use that division rule to simplify your w's. So you have 343 w squared over 16. One more problem to go here. We're going to raise negative 2 to the 5th power. Keep in mind that we must keep it in parentheses. We will use the product rule and do 3 times 5 to get x to the 15th. We have y to the 0, which is 1. When we do 0 times 5, that's still going to stay y to the 0. You don't even need to write it. And then we have z to the 1 times 5 is 5. Now we have to do everything in the denominator to the 5th power as well. So we're going to have 4 to the 5th power, x to the 5th power, z to the 10th power. And now we must simplify. When our base is odd, or when our base is negative and our power is odd, our result will remain negative. So 2 to the 5th power is 32. X to the 15th. Y to the 0 is 1. Z to the 5th. 4 to the 5th power is 1024. X to the 5th. Z to the 10th. I am now going to simplify my fraction of negative 32 over 1024, and that will simplify to negative 1 over 32. So for now I'm going to write a negative over 32 until I know what I need in my numerator. As I simplify my x's, and I'm going to do 15 minus 5, I get a positive 10, so I will have x to the 10th. And when I do my z's, I will have 5 minus 10, and I will get z to the 5th. And there is our final answer. Below in this chart is a review of all of the rules that we discussed in section 4.1. So we start with the product rule, the quotient rule, the power rule, raising a product to a power, and raising a quotient to a power. If you have questions about any of these rules, please contact me and I'll be more than happy to go over them with you and even provide you with extra examples if necessary. Thank you.